All right, we're taking a look at problems 1, 2, and 3 on the horizontal projectile motion review. So problem number 1, baseball pitcher throws a baseball in excess of 41 meters per second. If a ball is thrown horizontally, so the straight line is the path, the direction that he's throwing it, but the dashed line is how it's actually going to be moving, how much will it drop by the time it reaches the catcher, who's 17 meters away from the point of release? So 17 meters is how far away they are from each other, so that's the displacement in the x direction. The velocity is in the x direction because he's throwing it horizontally, so that's also right here. We're looking for d in the y direction, how far it's going to be falling, and the initial speed is 0 because he's throwing it horizontally, and the acceleration, because it's in midair, is negative 9.8 meters per second squared. I'm trying to find the d in the y direction, but I need 3 numbers. I only have 2 numbers, so I'm going to have to go to the x direction, solve for time, and then use it in the y direction in order to solve for what I really want, which is the displacement in the y direction. So in the x direction, I have one equation for constant velocity motion, that's d equals v times t. Rearranging for time, I get displacement over velocity. I can plug in my numbers, 17 meters divided by 41 meters. Tell me the baseball is going to get to the catcher in 0.41 seconds. Now that I have the time, I have v naught, I have a, I have t. I'm going to use the third kinematics equation, which is d equals v naught t plus 1/2 at squared. Since v naught is 0, the v naught t term just cancels, and I get d equals 1/2 at squared. I'm going to plug in my numbers of 1/2 times negative 9.8 meters per second squared times 0.41 seconds, square that number, and I get d equals negative 0.82 meters. That's how far the ball is going to fall. Number 2. A student stands at the edge of a cliff and throws a stone horizontally over the ledge, so the velocity is going to be in the x direction. He throws that stone with a speed of 18 meters per second, so that's why we have the number here. That's why the number is in the velocity column, or the velocity section of the x column. The cliff is 50 meters above the flat horizontal beach, so the 50 meters is right here. That's a vertical displacement. With what horizontal and vertical speed does the stone strike the ground? So I want to know how fast it's moving in the x direction and how fast it's moving in the y direction when it gets to the ground below. Well, in the x direction, the velocity never changes. It's constant velocity, so when it gets to the ground, it's still going to be moving 18 meters per second. In the y direction, I know it's going to fall 50 meters. The initial speed in the y direction is 0 because it's being thrown horizontally. The acceleration is negative 9.8 meters per second squared, and I'm solving for Vf. I'm going to use the fourth kinematics equation, Vf squared equals V naught squared plus 2AD. V naught is 0, so that term just goes away, and I get Vf equals the square root of 2 times the acceleration, negative 9.8 meters per second squared, times the displacement, which is negative 50 meters, and that gives me a final velocity in the y of negative 31.3 meters per second. Your calculator is going to give you the positive, but remember, it could be positive or negative, and negative is the one that makes sense since it's going to be moving downward. And the velocity in the x remains unchanged the whole time, 18 meters per second. Number 3. Tom the cat is chasing Jerry the mouse across a table, and that table is 1.5 meters above the floor. So there's our vertical displacement. Jerry steps out of the way at the last second, and Tom slides off the edge of the table with a speed of 5 meters per second, and that's going to be horizontal. Where will Tom strike the floor? So we want to know the displacement in the x direction. And what velocity components, or what x and y velocity, will the cat have just as he hits the ground? So I'm looking for the displacement in the x, and I'm also looking for the velocity in the x direction and the velocity in the y direction when the cat hits. So first things first, we'll take a look at the displacement in the x direction. Now we only have one equation for displacement in the x direction when it's constant velocity, and that's d equals v times t. The problem is I don't have the t yet. That was not given in the problem. So I'm actually going to go to the y direction to solve for time, because I know the vertical displacement, it's downward, negative 1.5 meters, initial velocity 0, acceleration negative 9.8 meters per second squared. With 3 things, I can solve for time. Using the third kinematics equation, right here, v naught is 0, so that term goes away, leaving me with d equals 1/2 at squared. Solving for time, I do the square root of 2d over a after I do a little algebra, plug in my numbers, and I get a time of 0.55 seconds. That's how long it's going to take the cat to get to the ground. I can plug that in over here in the x direction, d equals v times t, to know that the cat's going to go 2.75 meters in the x direction before hitting the ground. So that's the dx. That's one of the things that we were asked for. Now is asked for the components of velocity when the cat gets to the ground. Well, the x velocity never changes, so that's going to remain 5 the entire time. In the y direction, we have to find that. We're going to use the fourth equation. We could use any equation now that we have time, but I'm going to use the fourth one in case you solve for this first. And the vf squared equals v naught squared plus 2ad. V naught is 0, so that term goes away, leaving me with vf equals the square root of 2ad. Plug in my numbers, and I get negative 5.4 meters per second. Again, your calculator is going to give you the positive. You want the negative because anything coming out of the square root could be positive or negative, and it's moving downward.